Inheritance in C++ is a fundamental or a basic concept of object oriented programming where one class inherits or gets the structure of another class. A class which inherits is called derived class, and a class whose structure is inherited is called base class. Structure of the base class, which is inherited by the derived class, includes properties, which is data members, and behaviors, which is function members. This inheritance is an object oriented feature which promotes reuse of the code. Uh, Base class code is reused in the derived class. A derived class object can use not only the data members of the base class but also the function members of the base class. Inheritance also enables us to implement something called dynamic polymorphism, and also it allows us to design systems or objects by extending existing objects. Let me talk more about inheritance using this code. I don't have anything in this code except this preprocessor directive and the empty main function. When I want to talk about inheritance, you want to imagine two things. For example, if you want to have inheritance, then there is something that should be inherited to some other things. So you need to have two things here. For example, there could be this something in this place. Something has to have something that the other thing will find useful. Accessing or inheriting. For example, the most common example here is if you consider something as one of the things that you have been seeing every day in your life, dog, right? So dog has something that can be inherited by something called you can say domesticated dog, or dog has something that can be inherited by what you can call as a wild dog, or dog itself can be other thing which can inherit things from um, uh, animal, because animal has certain things features that dog also has, because dog is a kind of animal. So if you have this kind of situation, then you can think of these things be things that can fit in inheritance relationship. So basically inheritance is a relationship between two types in C++. Particularly two user defined types. So here, for example, in this case, I can have dog class, and I can have cat, but both dog and cat can have features like let's say name. If I create dog class, I can have this data member name, and dog can have as information. Now if you have these things common, then this is using this information or this attributes or these features in both classes actually amounts to repetition of the code. to minimize that repetition, what you can do is you can create a class called animal, and you can put these things in the animal class, and you can actually inherit that those data members from animal and use in dog and cat class. That is how, therefore we don't have repetition of the, I mean the logic, the code. We can minimize the amount of code we can place uh, in our code. So so now let's suppose that this is we have animal class with this I mean attributes. In addition to this, you can have you can think of other attributes uh, such as weight, because the things you put in the animals should be applicable to all the animals. So all the animals have a name, all the animals have age, all the animals have weight, and also you can also have whether that animal is domesticated or not domesticated feature, and all the animals have this attribute. So I'm not I mean putting this other additional attribute for the sake of the simplicity of the code. I stick to this two attributes, and in addition to that I want to have a public member which actually, let's say, sets name, let me have set function which returns void. It doesn't return anything. It receives name. Let me call this parameter name, and parameter ps, and it will actually validate if not null ptr, then you have else. You copy as information, and you also copy. The assumption here is that pname does not contain a string I mean with a length more than 31 characters. That is the assumption. If you want to avoid that, then you need to do additional, I mean you need to make some changes in this logic. So it does copy the data, and we want to have another function to display the data. So we have this this class, animal class. Then and you can create this dog. Dog is not at this point. This is not a derived class. This is independent class, independent of this animal. We can make this dog as a derived class of the animal using this syntax. After the class name, you put colon, and then you put keyword public, then name of the base class. So this syntax will actually make this dog as a derived class. That means dog has these things inherited. So if even if I don't put anything here, I should be able to use that this function through the dog class. Let me stick to the dog class because of time limitation. I'm going to let me skip the cat. With this thing, we have a dog class, and dog is inheriting everything from the animal. So you can create an object of dog class, and then after that you can call the set function, because this function is inherited by the derived class dog. Let me just write dog is, and animal is base class. Now we can call set function, and we can pass the first name followed by age. So if your dog if you I mean call your dog by the by the name, let's say Sari, and your dog age is, let's say, 3 years, 4 years, then this function will actually take this data. um, Even this is an object of the derived class, but it will actually take this data to this function, and it will set to this attribute, and these attributes are also inherited by the this dog class. Then after that I can call the print function, which will, we should invoke this function and display the data, right? So let me switch to the terminal and try to see whether this code gives me expected output. This is the command to do compilation and linking. So we actually needed to include the library string for strcpy function we have used. So for this function we need to include string include to the terminal. Now let me execute it. So now it is displaying, right? So we actually use the derived class object, but we are able to access the base class, not only the member function, set and print function. We also are able to access the data members, because this data is actually stored in those data members. Now typically what happens is you have animal class. This base class has the attribute behavior, which are actually common, useful to all the possible derived classes, like for the dog, for the cat, for the horse, for any other animals. But typically the derived class has its own unique attribute, right? For example, in this case, let me consider the dog has additional attribute breed, and we can have the function member function for the dog class. We don't need the function to set the data for the base class. We can make use of this function. I want to have a function to set the data for the dog class. Set breed, and this is the default data for this static character array. And if p breed is not equals to, then so this is the set breed function we have, and also we want to have print. Let me call this print beep. I want to make intentionally make this name different from the base class name, because it has inherited this base class function, so I don't want this function to actually match with this one. The reason I will talk about this, I mean something called shadowing effect in one of the future videos recording, but now I'm not. I want to make sure that this name do not match. So I would like to just print the breed. So now with this functionality, we can do additional setting dg dot set breed, and the breed I'm going to set is Labrador, and in addition to printing the base class data, I would also want to print B. Right, so we're invoking the base class function, and we are also invoking the derived class version of the function through the same object. Back to the terminal, compilation, linking, and execution. Now we have name, age, and this breed also displayed. Okay, let me talk a little bit about this syntax. So here, this keyword public is actually this is a keyword for specifying the mode of inheritance. This will be talked in detail in one of the future recording. And yeah, just one thing you should note here is the base class has some attribute, the derived class has some additional attribute, because it will automatically be able to access the base class attributes, and base class has this function, and it has some additional function for the extra purpose in addition to the base class function. So this is the actually purpose for which we actually want to have a derived class from the base class. So for this inheritance, base class and derived class, I would like to stop here. I will discuss further details in the next recording. Thank you for watching this video.